Okay, we're talking about continuity at a point in this section here. But in this particular problem, this piecewise function h of x, what we're going to try to do here is find a. And it's not going to be too bad. But these are kind of typical questions that you might find on a Cal 1 exam. Alright, so we go through the procedures of testing for continuity at a point. Now we're concerned about at 0 here. Okay, this is where these two functions here are going to be connected. And this is just more or less a straight line here, and it's continuous, right? X is greater than 0, and this is continuous for x is less than 0. But at 0 is where we're concerned. So we follow through with remembering the three properties for a function to be continuous at a point. So first thing I'm going to do here is I'm going to evaluate it at 0, so h of 0. Now, I'm going to be plugging 0 in the bottom one here because the domain of this part is x is greater than or equal to 0, so this means it includes 0. So therefore we're going to plug 0 into this guy here. And so we get 8 minus 2 times 0 is equal to a. Right? And then what we want to do is take the limit of 4 sine x over x, and we're coming in from the left-hand side, and then we're going to take the limit as x approaches 0, and we're going to come in from the right-hand side, because remember in this function here, it's less than 0. Right, all values less than 0, so we're coming in from the left, and this one we're coming in from the right because this is all greater than or equal to 0. So we come in from the left at 0, and that limit is going to be 4. Now, in some previous sections, solving limits analytically, we pretty much showed this is equal to 4. So I'm just going to assume that you know that this limit here is equal to 4. Okay. And coming in from the right hand side, we do the direct substitution, plugging 0 directly in, and we end up getting a. So now what we're going to do is we're going to set both these equal to each other. Right, 4 is equal to a, so that's pretty simple. Now the reason we're setting both of these equal to each other, because remember that we're testing the limit as x approaches 0, not from the left or from the right, but just approaches 0, which implies from the left and from the right. Okay, and in order for the limit as x approaches 0, right, of our function h of x, both of these must be equal to each other. So that's the reason we set these equal to each other. And it's pretty simple. Let's take a look at the graph. So this is the graph of our function. Now this is the one with the 4 sine x over x, and then it's connected right here, okay, where x is 0. And then this was the straight line, this was the other part, the 4 minus 2x. This would be the 4 minus 2x right here.